Welcome back to PD Online. And today we're going to introduce Newton's second law. So if you recall, Newton's first law simply says that an object in motion is going to stay in motion until acted upon by an external force. So Newton's second law is going to start looking at what happens if we have a net force acting on it, or conversely, what happens if we don't. You've probably heard the equation F equals ma. However, a more appropriate representation would be using the sigma, which means the sum of the forces, or this might be something you've seen before, the net force. And what that means is that after we add up all of the forces, if there's an unbalanced force, that's going to cause the object to accelerate. So remember, for an object to accelerate, it has to have an unbalanced force or a net force. For an object to stand still or move at a constant velocity, then the net force is 0. So let's take a look at a couple quick questions. It says, what is the net force required to accelerate a car at 2 meters per second squared if the car has a mass of 3150? All right, so my acceleration is 2 meters per second squared. The mass of my car is 3,150 kilograms, and we're looking for the net force. So in this case, I could just write F, and that would be perfectly appropriate, since we're really only going to have this one force acting in the direction of the acceleration. So I'm going to say F equals ma. The force that I'm looking for is equal to the mass. Well, since my mass was 3,150, I'm going to substitute that in where m goes. My acceleration is 2. That means my force, my net force, is going to be 6,300, and since it's a force, that will be newtons. This time we're going to be asked to find the mass of the truck if it's got a net force of 100 or 14,000 newtons acting on it while it's accelerating at a rate of 5.5 meters per second squared. I know that's my force, and since there's just one force, it's going to be quite straightforward. We just say 14,000 newtons, and it's accelerating at a rate of 5.5 meters per second squared. Remember, the unit can be your guide, so my acceleration is 5.5 meters per second squared, and the question is, what is the mass? So using that the net force equals ma, well, in this case, this is the only force acting on it, so that is my net force. That's going to give me 14,000 equals the mass times 5.5. The mass then of my truck is going to be 2,550. 2,550, and what unit goes with that? And that would be a kilogram. We want to know what is the acceleration of a softball if it has a mass of 0.5 kilograms and hits the catcher's glove with a force of 25 newtons. All right, so we have the mass here, and the mass is 0.5 kilograms. And it hits the catcher's glove with a force of 25 newtons. And the question is, what is the acceleration? So I want to find the acceleration of my softball. So using the fact that F equals ma, these are very simple cases, so just doing F equals ma is going to be perfectly appropriate. Equals 25. This is 0.5 times my acceleration. My acceleration then would be 50 meters per second squared. Now later we're going to find out that that really should be negative because isn't the softball slowing down as you catch it? All right, these are pretty straightforward. I think you'll have good luck with it, and we'll see you next time.